All right, let's get right into it. Right now, everyone's talking about large language models, right? We hear about agents, about the next amazing AI copilot. But for this explainer, we're going to focus on what seems like the boring part. The piece of the puzzle that, it turns out, is way more important than the LLM itself if you actually want to build a useful AI product.
This question right here is everything. It is the absolute make or break challenge for any team trying to build an AI application for the real world. Why? Because an AI that can't find the right information is just guessing. And you can't ship a product that's basically a glorified magic 8-ball.
So, what is this core problem we're talking about? Well, it's that an LLM can be a genius, but its brilliance is totally worthless if it can't tap into your specific knowledge. The model might know everything that's on Wikipedia, but it knows absolutely nothing about your company's internal policies or your customer support history. And this is where all that mission-critical knowledge is hiding. It's not sitting in some nice, clean database. No, it's locked away in super valuable but incredibly messy, unstructured data. Just think about it for a second. All the real, hard-won expertise of your entire organization lives in PDFs, support tickets, Slack messages, formats that are a total nightmare for a computer to understand. And this brings us to the absolute heart of the matter. We've gotten incredibly good at the generation part, at making AI that can write well. The truly difficult part, the thing that separates a cool demo from a tool people can rely on, is retrieval. It's about finding that one right piece of information in a gigantic, messy haystack of data.
So you might be thinking, okay, but why can't we just use what we've always used? A good old-fashioned search bar. Well, it turns out that our traditional way of finding things, keyword search, is just completely out of its depth here. It's not built for this new kind of challenge.
Here's a perfect, simple example of the problem. A developer asks, how do I rotate API keys, but your internal docs only talk about credential renewal? A keyword search is going to come up with absolutely nothing. It totally whiffs because it's just looking for matching words, and it's completely blind to the fact that these two phrases mean the exact same thing. And that's the whole disconnect, isn't it? People search for concepts. We search for ideas. We're looking for meaning. We're not just typing in an exact sequence of letters that we hope happens to be in a document somewhere. Keyword matching just can't keep up because it fundamentally doesn't understand our intent.
So if keyword search is the problem, what's the solution? How do we build a system that can actually search for meaning? This is where a whole different kind of technology comes into play, one that's specifically designed to bridge that semantic gap we just saw.
The solution is built on this really powerful concept, semantic similarity. Instead of asking, do these two sentences have the exact same words? We get to ask a much smarter question. Do these two sentences mean the same thing? And let me tell you, that shift is a total game changer. Okay, to make this feel a little less abstract, let's use a simple analogy. This is honestly one of the best ways I've found to really get a handle on how all these pieces fit together to create a system that feels truly intelligent.
Okay, so think of your large language model as a brilliant professor. This professor can write a beautiful, eloquent, perfectly structured essay on any topic you give them. But they have a terrible memory. They can't recall any specific facts from your documents. Now, the vector database, that's the superpowered librarian. This librarian has read every single document your company has ever created, and they can instantly find the exact right passage the professor needs to write a factual, accurate, and trustworthy response.
All right, so this superpowered librarian sounds pretty great, but how does it actually work? What's going on under the hood that makes this new kind of search possible? Let's break down the engine. It's basically a three-step process. First, you take all of your content, all those PDFs, emails, wikis, and you convert each piece into a list of numbers called a vector. You can think of this vector as a mathematical fingerprint for the meaning of the text. Second, you just store all of these vectors in the database. And third, when a user asks a question, you convert their question into a vector too. Then you just ask the database to find the vectors that are mathematically closest to the user's question. That whole process, finding relevant info to help the AI generate a better answer, that's the R in RAG, Retrieval Augmented Generation. So let's bring this all together. What does this actually mean in practice? Well, getting retrieval right unlocks a whole new world of applications, and getting it wrong leads to a very specific and very frustrating kind of failure. When you master retrieval, the payoff is huge. You're not just building a slightly better chatbot, you're unlocking true semantic search that understands what your users actually mean, not just what they type. You can build recommendation engines based on conceptual similarity. And most importantly, you get RAG systems that produce answers that are grounded in your actual documents, answers you can trust.
But when retrieval fails, you get this. And this is such a critical point. Without a solid retrieval system, your fancy, expensive AI is just a confident but totally unreliable storyteller. It will generate these beautifully written paragraphs that are completely factually wrong. It's the phenomenon we all know as hallucination, and it will kill your product's credibility.
So I'll just leave you with this question to think about. As we're all building this next generation of AI tools, we really have to ask ourselves, what's the most important part? Is it the model that can write the pretty words, or is it the library that can find the hard facts? The answer to that just might change how you look at the entire AI landscape.